Hello and welcome back to my math channel, and today I'm going to be going over lesson 1.2, rates of change through the AP Pre-Calculus curriculum. And so let's get like straight to the point. So the rate of change is also known as the slope of a line. You should know this from past geometric classes and past algebraic classes. Okay, so the rate of the change, as mentioned, is the slope of the line. Well, you're probably wondering, what is the equation for the rate of change? Well, the equation for the rate of change is also known as the change in y over the change in x. And here are some different ways you could use this. This formula is very important because throughout the whole pre-calculus journey, you will always be given this graph and you will always need to figure out the rate of the change. And soon, in a couple more videos, we'll be learning the rate of change of the rate of change, which will soon identify whether your graph, without even having a visual representation, is a linear graph, quadratic graph, or basically what it's raised to the exponent. So, following that, as I mentioned, knowing the rate of change formula is very important because this helps you with other classes such as physics, and what I'm taking currently, AP Physics. Well, the change in y usually signifies many different things. Furthermore, here's a simple example. Well, as we discussed earlier, that the slope of the line is also the rate of change. So let's say they give you this simple linear graph, and they're giving you the task of finding the rate of change throughout this graph. And so normally what I do is I pick points in the graph which seem to be more consistent, because obviously you don't want to get a point that's like hundreds of units away. It may work, but to be more precise, the closer you can get with being consistent is always the key. So you're probably wondering, how did I get these points? Well, as mentioned, I picked 2 points in the graph which were most consistent, which were 10,5 and 5,2.5. And now we just put this into our formula of change in y over change in x. So these little things on top, which say x1 or y1 and x2, y2, they don't really matter in which order you put them, but I always want to associate the y2 and the x2 with the farthest point. And the y1 and the x1 with the closest point. In this case, this one, the y1 and the x1 would be this one, and the x2 and the y2 would be this one. So now that you have your points established, we could finally put this into our formula. So as mentioned, our y2 is 5 minus our y1, which is 2.5. All of that being divided by our x2, which is 10, minus our x1, which is 5. And when you simplify out this, you should be left with 2.5 in the numerator and 5 in the denominator. And when you simplify that, your slope of the line should be equal to 0.5. So that means the slope of this line, it's constantly increasing by 0.5. So here is another example. What is the average rate of change from the interval from 13 seconds to 25 seconds? You're probably wondering, well, what points are we using? Well, they gave us if you think about it, they gave us 2 x intervals, which are 13 and 25. And so as we established before, to find the rate of change is equal to the change in y over the change in x. And don't be confused by these notations where t is the time in seconds and distance is the d times the d of t. So we could just replace these with x and y. So furthermore, we could establish our points being 25, 30, and 13, 76. and my x2 would be 25, and my y2 would be 30, and my x1 would be 13, and my y1 would be 76. And so we just plug these into the formula, and so in the numerator it should be 30 minus 76 being divided by 25 minus 13. And if we simplify that, our fraction should be negative 46 divided by 12. And if we simplify that even more, our rate of change through these intervals should be negative 3.833. Here is another wonderful example and a different type of question that you could be asked. What is the rate of change at a point? And if we read the question, it says, estimate the rate of change at x equals 1 from the function for the function f of x is equal to negative 1/2 x squared plus 3x minus 1/2. Well, you're probably wondering, how do we figure out our intervals? Don't panic. Well, since we're given x is equal to 1, we could just replace wherever we see x in the function with 1. And if we, like this little diagram shows, or this little explanation shows, replace everywhere where there's an x with 1, and your y value, which is f of x, should be 2. That's how we got this. And so you're probably wondering, we have 1 point, but to figure out the rate of change, we need 2 points. How are we going to do it? Well, when you're not given a point, or when you're not given a second point, you always want to go closest to the number that they gave you. So in this case, they gave us x is equal to 1. So we want a number that's very close to x, very close to 1, but not exactly 1, because they would just give us 2, and then the rate of change would be 0. So we can use 0.999 or 1.001. Well, in this case, I'm just going to use 1.001. So we put 1.001 in our x value. And now, just like what we did in the first part where we figured out 2, we plug 1.001 everywhere where there is an x, and your answer, or your y value, should come up to be 2.001. Now that we got our 2 points, we can figure out the rate of change. So this is going to be our y2 value, and our x2 value, and our x1, and our y1. Now we just plug it in. So our y2 is 2.001, and remember, that has to be subtracted by the y1. So 2.001 minus 2 being divided by 1.001 minus 1. And when you simplify that, sorry for that, I have no clue what that is, it's trying to autocorrect it. But if you simplify that, your answer should be left with 1.999. And if you just round up, your answer should be 2. So the rate of change throughout this function, based on that 1 point they gave us, and we estimated a number that was closer to that, is 2. So the rate of change for this function is 2. So here is another question that you could be possibly tested on. Positive and negative rates of change. So sometimes they don't even give you numerical values or a function, and they give you a word problem that you have to figure out to be the rate of change. So here are some brief little definitions. A positive rate of change indicates that a quantity increases or decreases and the other quantity does the same. A negative rate of change indicates that as a quantity increases, the other decreases. So let's look at some examples. As Mr. Bean's weight decreases, his running distance increases. State whether the situation represents a positive or negative rate of change. So the negative in the numerator represents Mr. Bean's weight decreasing. That's why it's a negative. And his running distance increases. That's why the denominator is a positive. So as we learned in past geometric and algebraic classes, a negative being divided by a positive is a negative. That's why the rate of change is a negative rate of change. The other example is, as the years increase, a high school student's body increases. So, state whether the situation represents a positive or negative rate of change. So, as the years increase, that's why it's a positive in the numerator, being divided by the student's body increasing. So that's another positive. And as mentioned, a positive divided by a positive equals a positive rate of change. So that is the end of the notes, the 1.2 notes, rates of change. Hope you enjoy the video, and don't forget to like and subscribe. And yeah, if you have any suggestions for me and what I can improve recording these videos, please shoot them down in the comments. And here is a try-at-home question that you guys could solve, and the answer would be posted in the next video or in the credits of the next video. Well, thank you for watching once more, and you're going to do great in your AP Pre-Calculus class.